Hi everyone, welcome to G World of Academic Physics. Today we will discuss the electric field at the center of a uniform circular arc. What I will consider a circular arc, this is a circular arc and this is exactly the center of a circular arc. I'll simply trying to draw this. Yes, this is exactly the center of the circular arc. And I said this circular arc charge Q is uniformly distributed over this circular arc. Positive charge Q is uniformly distributed on the surface of circular arc, and lambda is the line charge density. Line charge density. And lambda is what? Line charge density. We need to find the expression of electric field at the center of this circular arc. And this arc subtended an angle theta. This arc subtended what angle? This total angle is theta. When this kind of questions is given to us, this is an extended body. I'll simply bisect it. Exactly want to bisect. Yes. And I said this angle, if total angle is theta, this angle is theta by 2 and this angle is what? Theta by 2. When the extended object questions have been given, I will simply consider a small element. This is my small element. And I said total charge is Q and this small element, the charge is dq. And the length of this small element, I said this length is dx. And I connected it like this. And I connected it like this. And I say this is phi and this is d phi. Whatever the element I preferred, this element angle is d phi. From phi, I consider a d phi element and whose charge is dq and length is dx. So I just want to redraw the same scenario here. This is dq. The charge here is dq and the length is dx and this radius is r and this angle is d phi. So using that concept, can I say dx equals to r d phi? Yes, because d phi equals to angle equals to arc length upon radius. So dx equals to r d phi. This is the thing I can say. This is the important result that I have to be in my checklist. This is dq. Exactly at this point, I need to find the expression of electric field at this point O. When this question is asking like this, I must introduce a test charge. This is dq and here a positive test charge. You need positive test charge. Positive, positive, what will happen? It will repel like this. This is the expression, this is the direction of the electric field. This is positive, it will repel like this. How many components? Two components of the electric field. If this is phi, this angle is phi, so this angle definitely phi. So this is dE cos phi and this is dE sin phi. I hope the scenario is clear to everyone. If the same symmetrical element I will consider here, if I will consider the same symmetrical element and same way phi to d phi if I will consider, I just want to draw it in a better way here and here, and again I will say this is d phi, so it will be electric field will be like this because here it is dq. Electric field direction will be like this. And how many components? Two components. One is dE sin phi, because if this is phi, this angle is phi, this angle also phi. So this is dE sin phi and again this is dE cos phi. So what will happen? Due to symmetrical pattern, this dE sin phi and dE sin phi equal in magnitude but acts in opposite directions. These two components will cancel. The only components are dE cos phi due to this element and dE cos phi due to this element. I already said my previous lectures, we must not do like 2 dE cos phi. No, this is an extended body and these elements are the same part of the body. It is elements are the same body. It is not two different things. So rather than adding these two things, I must say the net electric field is nothing but integration of dE cos phi rather than 2 dE cos phi. If it is negative, if it is positive, then these are two different things, then in that case 2 dE cos phi. But this is positive and it is the part of the same body, both having the same. So we cannot like 2 dE cos phi, this is dE cos phi. What is dE? dE due to this charge at this point we are writing. So expression is k dq upon r square. This is what? Cos phi. What is dq? dq can be written as lambda dx upon r square. This is cos phi. I hope the scenario is very clear. And dx can be written as what? K lambda. Dx can be written as, look at here, dx is r d phi. So dx I will simply substitute here r d phi upon r square cos phi. This is my angle. So what is the expression is coming? K lambda. This r has been cancelled. This is r. The integration is cos phi d phi. And what is the limit of the integration? This is very important thing that you have to be in your checklist. Look at here. If I'll consider my element here, the angle phi is 0. The minimum is 0. Maximum it can goes from here to here. So 0 to theta by 2. 0 to I can go maximum here. And 0 to I can go here minus theta by 2. So can I say, if I'll consider my element here, this is minus theta by 2. If I'll consider my element here, this is plus theta by 2. So 0 to plus theta by 2, 0 to minus theta by 2. So student must be aware about these things. This is minus theta by 2 to plus theta by 2. This is very important thing that you have to be in your mind. I have to write it here to be better view. So what is my expression is coming? This is k lambda by r integration of cos phi d phi minus theta by 2 to plus theta by 2. If this is the integrations, we all know k lambda by r integration of cos theta or cos phi is sin phi, and this is minus theta by 2 to plus theta by 2. So what is the expression? That is k lambda by r. If I'll put my upper limit, this is sin theta by 2 and this is sin minus theta by 2. And we know that sin of minus x is what? Minus sin x. Cos of minus x equals to what? Cos x. So sin of minus x can be written as what? Minus sin x. So I just simply write it as k lambda by r. This is sin theta by 2 minus, here can be written as minus sin theta by 2. So the expression minus giving rise to plus, the expression will be coming as 2k lambda by r sin theta by 2. This is the expression of net electric field at the center of any circular arc. This is my expression, that 2k lambda by r sin theta by 2. This is very important result, and this important result can solve some of the good competitive questions that already asked in the papers. Let me do some of the applications based on this. Suppose the semicircular arc has given to you. This is a semicircular ring, you can say, having total charge is q, and line charge is lambda. This is positive. Using this expression, that 2k lambda by r sin theta by 2, can I predict what is the expression of electric field at the center of the ring? Yes. If we consider the whole theta is now what? It is pi. If I will write my net electric field, E net is nothing but 2k lambda by r, this is sin pi by 2. And the expression is simply 2k lambda by r sine 90, it is answer is 1. So what is the expression? That is 2k lambda by r for a semicircular arc. And what is the direction of the electric field? See, this is a positive charge. This is what? A positive charge. So positive, if I find the expression of the electric field, I must introduce the test charge here. This is positive, this is positive. So it will be, the direction will be like this. So one can also write, if it want to be a vector form, so direction is minus j cap, because this is x and this is y, the direction is downward, because positive it will be repel like this. If someone will consider this is negative charge, then it will, what will happen? The direction is upward. This is, you can say 2k lambda by r plus j cap. This is for what? Semicircular arc. If the semicircular arc or semicircular ring, one must aware about the thing that how to approach this question. Let me move on to some of the other applications based on this. Suppose the question has given to you like this, a quarter arc like this. And we know the general expression is what? What is the general expression? That is 2k lambda by r sine theta by 2. So if a semicircular arc has given and the charge is positive uniformly distributed on this semicircular arc, and if the question is asking find the expression of electric field at the center of this semicircular arc, we know the angle is pi by 2. So directly one can put the expression that 2k lambda by r, this is sine pi by 2, it means pi by 4. The expression is what? So 2k lambda by r sine 45 can be written as 1 by root 2. So if I will do my mathematics, that is k lambda by r, this is 2, I will multiply 1 root 2 here, I will root 2 here. So this is root 2 k lambda by r. The expression of electric field is what? Root 2 k lambda by r. And if you see carefully, this is positive. I will bring a test charge here, that is also unit positive test charge. What is the expression of electric field? The electric field expression is root 2 k lambda by r. This is the expression of electric field, root 2 k lambda by r, and it will be like this. In exams also, this is what is the result you are getting, that is 2k lambda by r like this. Some cases also they can ask you, this root 2 k lambda by r, this is the overall electric field that you are observing. If I will break this root 2 k lambda by r, can I say this is one component like this? This is k lambda by r. There will be another component like this. This is also what? K lambda by r. So student must be very aware about this. This root 2 k lambda by r, whatever the result you are getting, this is combination of two things. One is k lambda by r minus I cap plus k lambda by r minus j cap. These two result magnitude is giving these things. So whatever the electric field we are getting, that is the final magnitude of the electric field. One option in one of the exam I have seen the scenario, the questions options have been set like this. This root 2 k lambda by r can be written as what? K lambda by r minus I cap and k lambda by r minus j cap. Suppose I will consider one more important question based on the applications of this. Suppose this is a scenario. Half of the sections is positive and half of the sections is negative. If the scenario has given like this, a semicircular arc where exactly half of the section is what? Positive charge uniformly distributed and half of the section is negative charge uniformly distributed, and question is asking find the expression of electric field at the center C. We know if this is a scenario, this is positive, the expression of electric field it will be go like this. This is negative, at this point a test charge is also positive, negative, positive, and it will be attract like this. This is the scenario have been like this. So this is exactly the electric field have been like this. It will go like this. This will go like this. Here the expression is what? Root 2 k lambda by r. Here the expression also what? Root 2 k lambda by r. If you carefully observe, this component is what? K lambda by r. If it is root 2 k lambda by r, if you observe very carefully these expressions, root 2 k lambda by r, here one component, that is k lambda by r, another component is what? K lambda by r. These two component magnitude will giving rise to this result root 2 k lambda by r. So this is k lambda by r, this is k lambda by r. Similarly, this is k lambda by r, and this is due to this, I will break it, this is k lambda by r, and this is what? K lambda by r. So k lambda by r equal and opposite, equal in magnitude but acts in opposite directions. What will happen? These two things will be cancel each other. So what is the net electric field? The net electric field due to this one component is k lambda by r, and due to this one, another component is also k lambda by r. So final answer is k lambda by r plus k lambda by r, and both k lambda by r, k lambda by r, both in what? In one direction. This is, you can say, I cap directions. Because due to this k lambda by r like this, another k lambda by r like this. Due to this k lambda by r like this, k lambda by r like this, and their resultant giving this root 2 k lambda by r, root 2 k lambda by r. So what is the net? You can say here is I cap, here also I cap. So we will get a result 2 k lambda by r I cap. This is the way that someone can approach these arc problems. I hope the scenario is pretty clear to everyone. Let me summarize. If you go for a circular if you go for any arc, the expression is 2k lambda by r sine theta by 2, and using that we have done for semicircular arc, quarter arc. Some cases the scenario has also given to you. Some section is positive, some section is negative. Based on the directions, you have to look into the things and you have to conclude the things. I hope the scenario is clear to everyone. Thank you everyone. Thank you for your watchings.